and we are setting up our server. And I am in DigitalOcean. You can choose whatever you want. All right, again, I'm not being paid for using DigitalOcean. I'm strictly using this as my server of choice. And within DigitalOcean, if you're following along, they call them droplets. I have a droplet for a previous website. Now I'm creating another droplet. Okay, choose the region closest to you. In my instance, I'm in Pennsylvania, so New York is the closest to me, where the servers live. Okay, for the operating system, we are using Linux Ubuntu. And for the droplet type, all I need is a basic type right now. Okay, and I am choosing premium Intel Core processors, non-volatile memory, solid-state drives as my hard drive. Okay, and 2 gigabytes of RAM. This refers to the amount of random access memory your server has. RAM is crucial for multitasking and performance as it temporarily stores data that your server needs to access quickly. And the more RAM you have, the more it allows your server to handle more users, run larger applications, and manage tasks more efficiently. 2 gigabytes is suitable for small to medium-sized businesses or applications. Okay, 2 Intel CPUs. This means the server is allocating 2 virtual CPUs based on Intel processors. CPUs, central processing units, are responsible for processing instruction and running applications. And having 2 CPUs allows the server to handle more processes simultaneously, improving performance, especially for websites with moderate traffic or applications with higher computation demands. Sorry about that. Not perfect. All right. And we are implementing 9 gigabytes of non-volatile memory, solid-state drives, a hard drive, 90 gigabytes of non-volatile memory, solid-state drives say that 3 times, refers to the amount and type of storage your server has. Non-volatile memory, SSDs, are ultra-fast, solid-state drives that offer faster data read-write speeds compared to traditional SSDs or HDDs. And here's a little example. The 90 gigabyte SSD will store your website files, database, and other data. Non-volatile memory, NVMEs, solid-state drives make file access and application loading much quicker, which improves your website's performance, especially when you're handling larger files or databases. Okay, and we have a 3 terabyte transfer. And an example, I'll explain it first. This is the amount of data transfer allowed per month. It represents the total volume of data that can be uploaded or downloaded from the server. I'll give a little example. 3 terabytes of transfer is the bandwidth allowance for serving web pages, media files, and handling other traffic. It's suitable for websites with moderate traffic, such as business sites or blogs with thousands of visitors per month. So just to summarize, we are implementing 2 gigabytes of RAM, enough memory for small to medium-sized websites or applications, 2 Intel Core CPUs, 2 virtual processors that help the server handle multiple tasks efficiently, 90 gigabytes of non-volatile memory, NVMEs, solid-state drives, hard drives, which are fast and efficient, storage for your data with plenty of space for website files, database, and backups. And we have a 3 terabyte transfer, which is the monthly bandwidth allowance that handles the data sent and received by your site. And I just wanted to explain what VPS is. A VPS is a virtual private server. It is a virtualized server that acts like a dedicated physical server, but it actually is hosted on a larger physical server, shares with other users, shared upon other users. And it's a great balance between shared hosting and dedicated hosting because it offers more control, flexibility, and resources than shared hosting, but at a lower cost than having your own dedicated server. And next, we will be going over setting up a SSH key, which I will take you step by step in doing so. See you then. Authentication method. I am going to be implementing SSH key pairs to connect to my server. I definitely do not recommend passwords as they can be cracked, stolen, given away. SSH key pairs are much more secure. You have vital information on your server, all your files, and you don't want that being tampered with. So we're going to go SSH key pairs, and I don't feel right in carrying on without giving you guys a little introduction on SSH key pairs. And if you already know about this, just go ahead and fast forward. I wouldn't blame you. But if you do not know anything about this, if this is a new concept, I highly advise that you stick around and listen to my introduction. Totally up to you. Let me sip my coffee. Need some sugar. All right, introduction to SSH and key pairs. SSH, Secure Shell, is a protocol that lets you securely connect to remote servers. It is primarily used for managing servers without having to physically be there. SSH uses encryption to protect the connection, which ensures that no one can intercept or eavesdrop on the data being sent. Instead of traditional passwords, SSH can be a more secure method called SSH key pairs for authentication. An SSH key pair consists of two parts. Okay, we have your public key. This key is stored on your server, the server that you want access to. Okay, it's safe to share, and it's used to verify if the private key is legitimate, the private key that's saved on your local machine. Okay, and the private key. This key is stored securely on your local machine and should never be shared. It is used to prove that you have the proper authentication to access the server. Okay, when you try to log into a server, your local machine sends the private key from your local machine to the server via SSH, which checks if it matches the public key stored on your server. If the keys match, the server grants access, bam, without requiring a password. Okay, and I do want to explain what .ssh is. .ssh folder. The .ssh folder is where SSH-related files are stored on your local machine. It is a hidden directory. The dot before the name makes it hidden in Unix-based systems like Mac OS or Linux. Inside the folder, you'll typically find ID_RSA. This is your private key file. Or ID_RSA.pub. This is your public key file. And that's the one that you share with your server. That's the one that you plug in here. Okay. And now we're going to go through a step-by-step guide on setting up the SSH keys on Mac and adding them to DigitalOcean. I'm using Mac OS Terminal. If you're using Windows, no problem at all. Just open up Windows and your terminal within it. Okay, let me open up my Mac OS Terminal. All right, here we go. Oh, and if you're using a Mac, press Command and Spacebar and type in Terminal and press Enter to open it, or you could just search for it manually. Okay, let's begin. Type in SSH, keygen, -T, -B, 409 and 6. Okay, explaining this, the -T RSA specifies the type of key RSA. RSA is widely used and secure. Probably it's the most secure encryption method. Okay, and the -B in it, 4096, this defines the key length with 4096 bits, providing strong encryption. Okay, so now that we have that typed on in, hit enter. Okay. right. Then you'll be prompted to choose a location to save the keys. Please press enter to accept the default location. Okay, go ahead and type in SSH -KEYGEN -T RSA -B 4096, enter. Okay, you have received a generating public-private RSA key pair. Enter file in which to save the key. We're going to keep it at the default location. This is my default location. Okay, hit enter. Now I'm going to overwrite an existing ID.rsa. You probably won't see this. This is your first time. Okay, if you want to skip the passphrase, I am. Double click, and there we go. Okay, we have gone ahead and created our key pair. And now we want to copy the public key. And now that we have generated the key pair, the next step is to copy the public key, which will be placed on the server, DigitalOcean. To do this, run the following command, which is cat /.ssh /ID_RSA.pub, and cat will pull this up. Okay, here is our public key, and we want to go ahead and take this and place it on DigitalOcean. We're going to put it right here. Okay. Let me get back to my terminal. All right. Copy from SSH-RSA all the way down to here. Okay. You don't want to copy this down here. This is your command line. SSH-RSA all the way down to here. So I'm going to copy this, and I'm going to place it on my public SSH key text box, which is stored on my server. And the private key is stored in that location that we stored it at. And it's an invisible file. Okay. Go ahead and name this. Okay, named it my pub. All right, so that's all good. Scroll down. You can check this if you want. Add improved metrics, monitoring, and alert time. I'm not going to do this. Add a worry-free managed database. Nah, good on that too, but it's up to you guys, whatever you guys want to do. And let me just go over this again to make sure everything's good. New York. Go to basic premium Intel Core processor. Oh, there we go. Yeah, I didn't need a 4 terabyte transfer speed. I'm just using 3 terabyte. And I didn't need as much non-volatile memory. So I'm using 90 gigabytes. I already went over this earlier. And I only need 2 gigabytes of RAM right now. If my site grows, I will upgrade, which it will. But for now, that's good enough. And also, I skipped the backups. If you want to enable automated backups, go ahead. And I'm going to do weekly backups. Okay, if you want to back up every day, go ahead and do it. Totally up to you. There's other ways to back this information up. Okay, I'll catch you. I'm going to create my droplet, and I'll catch you in the next video. Thanks. From Echo Frameworks here, and if you have gotten this far, congratulations. You should now see your first droplet and your IP address associated with. Okay, but we are working in Enom right now. We're going to update our domain DNS records. All right, so travel back to Enom. Go to Domains, My Domains. Click on your domain. Okay, and this is the hosting DNS section. We're going to update our records, but before we do that, I'd like to explain a little bit about DNS records. I don't feel right just blindly going over this or blindly plugging in values, IP addresses without explaining first. If you already know this stuff, fast forward. If not, I highly suggest you stick around and listen. Okay, you ready? Let's get started. Okay, understanding DNS records. Okay, the domain name system, DNS, translates human-readable domain names like godsgoldenquilt.com into IP addresses like 15.197.172.60. We already have our IP address from our droplet back in DigitalOcean, and which computers use to communicate IP addresses. They don't communicate via words, they communicate via IP addresses. Okay, different DNS record types serve different purposes. The most common ones include the A record, which maps a domain or subdomain to a IPv4 address. Next, we have the CNAME record, points one domain or subdomain to another domain, an alias. And we have the wildcard record, which covers all subdomains that aren't specifically set. And we're not going to use the wildcard, just the A record and the CNAME. Let's go ahead and go back to DigitalOcean. Okay, copy your IP address. Go back to Enom. Okay, first we're going to do the A record. Change this to A address. And plug in your IP address from your droplet. Okay, for the www name, the host name, this is a CNAME, and this is going to be your actual domain name. Mine is www.godsgoldenquilt.com, but I'm just going to type in godsgoldenquilt.com, and this ensures that if somebody types in www.godsgoldenquilt, or without the www, they are headed to the www.godsgoldenquilt.com. Go ahead and paste, or go ahead and type that in, not the www, just your domain. Okay. All right, so we have our host name, CNAME, domain name. Okay. And our A address. Go ahead and hit save. Okay, and this does take a few hours to propagate. So within a couple hours, and we do have tools where we can check propagation, the progress that it is making. And yeah, that's pretty much it for this video. We went briefly over hosting and DNS records. And on the next video, we're going to travel back to DigitalOcean and carry on. Thanks for sticking around, and hopefully I'll see you in the next video. And by the way, you guys are doing really great. This stuff can get pretty in-depth, and I mean, if you're persistent, you keep on learning and practicing, you're going to get really good at this stuff if you have the desire to do it. If you don't have the desire to do this stuff, I wouldn't even suggest, playing around with it, because you really have to want to learn this stuff. It gets very intricate. But not to discourage you. I'm only trying to give you guys a little bit of guidance. Yeah, so that's it. And I will see you in the next video. Bye-bye.